So let's start with chapter 1, section 2, angles and their relationships. And some of this information is going to be a repeat of what we've already been introducing along the way. But this is the time in the course where you should start to master some of these notations here. All right, so an angle is the union of two rays. A ray has an endpoint and then a line going off in a direction. These are called the sides, and the endpoint is called the vertex. So an angle has two sides and one vertex. This would be considered angle ABC. It could also be considered angle CBA. And since there's no ambiguity here, you could just call it angle B, because that's the only angle that has B as a vertex. And then the last thing, here's our new notation. You can number angles in the corner. See that little one? That means in any kind of calculation or any kind of statement referring to this angle, we can also call this angle 1. So that's going to be helpful rather than going through the three-letter or three-point name for an angle. You're going to see numbering of angles a lot more frequently now. So an angle, if we were to use set notation, is angle B was the union of ray BA and ray BC. For a ray, the endpoint is always the first letter named. And here's your postulate 8. The measure of an angle is a unique positive number. So the measure of angle B, that's going to be a number, that's a measurement. The measure of angle B must be positive. So just like line segments cannot have negative length, angles cannot have negative measures. And furthermore, there cannot be two different measurements. So angle B is, if it's 38 degrees, it can't be 38 degrees and 71 degrees at the same time. It's got to be unique and positive. And here are the different types of angles. We've covered this before, but here it is in a nice table for you. Acute angles have measures that are less than 90 degrees. Right angles have measures that are exactly 90 degrees. Let me try to get that a little bit better focused. Obtuse angles have measures that are greater than 90 degrees but less than 180. Straight angles equal 180 degrees. And then reflex angles are greater than 180 but less than 360. And a reflex angle will always have an arc on it. If an angle does not have an arc showing the reflex part, we would assume the acute angle. So in this figure, angle ABC contains non-collinear, these points are not all on the same line, points A, B, and C. So whenever you see an angle like this, we are always going to assume the acute angle unless you see the arc notation. Points in here are on the interior of the angle. Points on the sides are said to be on the angle. And point F, like point F, outside the interior or in the exterior. So just like we had the line segment addition postulate, we have the angle addition postulate. So if point D lies on the interior of an angle, there's point D, which is definitely on the interior of angle ABC, then the measure of ABD plus the measure of DBC is going to equal the measure of the larger angle. So this would be a number, this would be a number, and this would be a number. And we actually have some examples of that. Okay, so they want us to find the measure of angle ABC if measure of ABD is 27 degrees. Okay, so if this is 27 degrees and DBC is 42 degrees, we know that the measure of ABD plus the measure of angle DBC is going to equal the measure of angle ABC. So in this calculation, I'm going to replace the measure of angle ABD with what it's equal to, 27. Bring down the plus sign, and since they're degrees, you can keep the degree or not. The measure of angle DBC, we'll replace that with what it's equal to. Bring down the equal sign, and that's going to be the measure of ABC. So now I'm going to add 27 and 42. And I get 69 degrees. So that is the measure of angle ABC. And that's the angle addition postulate. Now for example B, I want to try to get away from all of these alphabet soup here. I'm going to call this angle 1. And I'm going to call that angle 2. And as long as your diagram is clearly marked with angle numbers, you can use them for your calculations. So now what we'll say is the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle ABC. And what is the measure of angle 1? Here in our problem we are told that's x. Bring down the plus sign. What is the measure of angle 2? In the problem, we're told it's 2x minus 3. That's going to equal the measure of angle ABC. So, just doing our algebra here, 1x plus 2x is 3x. Bring down the minus, bring down the 3, bring down the equals, and that's the measure of angle ABC, and that's your answer. We're going to leave it in terms of a variable. So now we're going to learn a lot about the different types of pairs of angles. These are relationships involving two angles, never more than two, never less than two. These two angles, I'll call it angle 1 and angle 2, are said to be adjacent. That's one way to describe those two angles. They are adjacent angles. Adjacent, means right next to, but in geometry we actually have a more formal definition of adjacent angle. So here's your definition. Two angles are adjacent if they have a common vertex and a common side between them, which that actually did. If that was A, B, C, D. They both have a common vertex B, and they both have a common side BD. A different definition are congruent angles. Congruent angles are two angles that have the same measure. They're the same size. So if you were to pick one angle up off the page and lay it on top of the other angle, if they would be the exact same size, their measures would be the same and they would be called congruent. So let's take a look at these two angles here. Here's angle 1, here's angle 2. We are told angle 1 is congruent with angle 2 if the measure of angle 1 is equal to the measure of angle 2. And another way to mark a diagram to show that angles are congruent is to use the same number of loops. This marking, this is not just something to make it pretty. This single arc and this single arc say that those two angles are congruent. They have the same measure. So here I have angle A and angle P. If they both have 3 arcs, I know that angle A and angle P are congruent angles. So a lot of this notation